All right, welcome back, you guys. We're here to tackle example 2 now, so get excited. Woo, woo, get excited. All right, but anyway, so example 2 is going to be really similar to example 1, except we are now applying the converse of the perpendicular bisector theorem, which the converse means we just reverse the statement, which the original statement states if a point is located on a perpendicular bisector, then it is equidistant to each endpoint of the segment that it is perpendicular to. Okay, so the reverse of that, or the converse of that, states that if there is a point that is equidistant, or the same distance to each point on a segment, that must mean it is located on a perpendicular bisector. So let's see what nifty things happen here. Okay, so if you see here, I need you to see if there's a point that is equidistant, or the same distance to two other points on a segment. Do you guys spot it? Do you see it? Holy hot dog. Do you guys see sneaky point R right there? Whoa. All right, so sneaky point R is the same distance, or equidistant to point S and point T. So that means it is congruent to each of these bad boys. And since there's a point that is congruent to two other points located on the same segment, that means that point R is located on a perpendicular bisector. So line RU is a perpendicular bisector. Yay! Which that means we can now use the perpendicular bisector theorem. Get excited. All right, so line R to the U is a perpendicular bisector. Yay! All right, so R to the U is a perpendicular bisector. Bam. Okay. Okay, so if you see here, we already see that RU is perpendicular to ST because it makes a 90-degree angle. That's a little boxy right there. Okay, and if it's a bisector, what that means is it slices the segment in half. So RU will slice segment ST in half, which means SU and UT. What does that mean about SU and UT? If this is the halfway point, how does SU relate to UT? Like normal, you guys always know the answer. That is correct. So if RU is bisecting ST, that means it creates two congruent segments, which in this case will be segment SU and UT. So SU and UT will be congruent, which will help me when we start solving for X. Okay, let's see here. Okay, so I know that segment SU is congruent to segment UT, which means that their lengths are equal. Look at that. Okay, so since the two lengths are equal, that means if my goal is to solve for X, look at this, you guys, SU and UT both have an X in it. So I can use these two segments to help me find X. So I'm going to substitute in what SU and UT equal. Let's do this thing. Our SU equals 2X plus 2, and U to the T equals 3X. All right, and from here, I just need to solve this thing for X. Let's do this, guys. We got this. We got this. Okay, so currently my X's are separated, which means I need to join the besties together. My 2X is a positive 2X. So the way that I'm going to move it over to the other side is by subtracting that thing on both sides. Bam. So 2X minus 2X cancels and turns to 0. 2X minus 2X is 1X, or just X. All right, and all I have left is an X and a 2. So guess what, you guys? X is 2. Nice. Well, that wasn't too bad, right? But we are not done solving because we need to solve for SU and for UT. Okay, so let's see. S to the U equals 2X plus 2. And U to the T equals 3X. So now that I know X is 2, how can I use that to find SU and UT? Holy hot dog, you guys. You would substitute in 2 for the X's. So let's do this thing and solve for SU and UT. So here I'm going to substitute 2 in for my X. So X will transform into a 2. That's my transform noise. But anyways, let's solve this thing. So 2 times 2 will be a 4. And 4 plus 2 gives me 6. So s to the u is 6. Oh, man. Okay, so we know that the lengths of SU and UT are equal. So technically, our UT should be 6, but it doesn't hurt to check, right? You know, we make mistakes. The demon cats get us. You know, it's good to check to make sure you did it right. So I'm going to double check because sometimes the demon cats get me, you guys. So I just want to make sure I did it right. So let's see here. I'm going to replace x with 2. Okay, this makes me nervous. I hope that it equals 6 because if it doesn't, well, I need to redo the problem apparently. Okay, let's see. CUT is 3 times 2, which, heavenly hamburger, you guys. It will be a 6. Yay! So we got the same thing, which again, I'm super excited, so I'm going to put a happy face. So I got the same thing. That means I did it right. So we have just applied the converse of the perpendicular bisector theorem. So get excited, you guys.